Hello and welcome back to my bench. Today to another repair video. So we have FT-857D here on the bench, and the radio came in with no TX power on RF, and as far as the old man told me, on VHF and UHF radio should be okay. Only on RF there is no TX power. Okay, so let's go according our normal procedure. Let's verify if we have the same findings here in the lab. And then we can go step by step and check what the problem is. So let's start in the 2 meter band, and I have dialed the 145.290 megahertz in, and I've already switched on my signal generator, and yeah, as you can hear, so we have receive on 2 meter, and now we want to verify if we can transmit on 2 meter. So therefore we want to watch the right upper display and now I'm keying the radio. Okay, and what we can see, we have almost 5 watt output on VHF, so that is nice so far. Okay, and to be sure that the RF amplifier in VHF is capable to go for the maximum power, I have put the power in the radio to a maximum, and now we should be able to reach 50 watt, and let's check. And yeah, 55 watt, so that is what we have on transmit on 2 meters, so that is good so far. Okay, and also in the 70 centimeter band we have receive. So that is what we can hear. So that is working. And yeah, let's check if our amplifier is working on 70 centimeter as well. And yeah, 55 watt. And oh, the radio is switching to 2 meters, so that is not what we want. So I've switched it, and now we are transmitting on 70 centimeter, as you can read on the left upper display, and we are sending out 5 watt, so that is the low level. And well, let's check if we can get full power. Yeah, set the radio to full power, and we are, yeah, it is approximately 19 watt, so that is fine. So well, we are sure that the transmitter is working perfectly on UHF and VHF, and so we can go ahead and check what we have on the RF bands. So Okay, you see that? So, whoops. So that that shows that the radio had some hard times. So the knob is gone. Yeah. Okay. So let's go and check our RF bands. Okay, on the 20 meter band, so let's check what the power will be there. Okay, so let's check. So I'm on the 20 meter band and no power at all. So there is definitely no power, so nothing. So let me change to 40 meter band. So now I'm on 7.100 megahertz. So I'm on the 40 meter band, and yeah, no power on the 40 meter band. So there is definitely no output, and so no, nothing. Let me go down to 3.5 megahertz, which is the 80 meter band, and yeah, no power on the 80 meter band as well. So this test is useful to check if there is maybe only one band where we do not have power, because in that case it could be that there is a problem with the low pass filter, with one of the low pass filters, but I have checked it now in 3 different bands, and we have in all these bands the same symptom. So there is definitely no power. So there is no power, and now we have to go ahead. Well, let's have a look to our block diagram, and what we can see down here is the exciter stage, and for us it is important to see on which bands are this exciter is working. And when we have a closer look to this area here, you see we have the RF band, and as well the 50 megahertz and the VHF and the UHF, which are going to exactly the same exciter, which is this down here. So we have the two SK2975, which is the driver and the pre-final, and this is on the main board. And well, so this transistors here are well-known MOSFETs, which are really known for making trouble. And in this case now we are sure that the fault is not on the main unit, and we do not have a problem with this really critical MOSFETs. So these MOSFETs are working, because other side we would not have any RF power on VHF and UHF, so that is fine. And in this case we can now go up there, because this here is the PA unit. So we seems to have a problem in the PA unit, and that is what we have to check next. Well, but there is one point I want to check before. I'm right now in the service menu, and I'm here on number 24. And yeah, let me go a little bit closer, then you might see it a bit better. And on number 24, I'm able to adjust the output power, in this case for the 160 meter band. And this here is the value where the radio has to set to. And well, we know that we normally want to have on CW maximum 100 watt, but in this menu you are able to increase your output power. So we have here a value of 169, and when I'm turning, yeah, let me do it this way here. So when I'm turning, you can see it right here. So when I'm turning the knob, so the main dial, I'm increasing the value, and the maximum value is 255. So that is maximum. And you know, there are hams out there who are tuning the radio to the maximum output power on all the different bands. So then you might have a transmit power of, I don't know, 140 or 150 watt. But you know, that is not really the best idea, because you are really stressing the final stage very much. And you know, this could be a reason that a final stage could die, because you know, the final produces more heat, and you know, the heat must get away. And with this setting it is difficult to get the heat away from the final transistors. So I never would recommend to put your maximum output power to 255. So let's go where it was set to, and it was 169, and that is definitely the right setting. And yeah, what I want to check, if the other settings are also on a normal value and not on the maximum. So therefore I turn until we have number 28, and there you can see we are on the 40 meter band. And well, so maximum is again 255, but it is set to 169 as well. So there is obviously no change, so that is okay. So let's do the same on 32, which is now the 15 meter band, and 167. So that is okay, no problem whatsoever. And now let's switch to 36, and we are now already on 50 megahertz, and that is set to a good value as well. And on 40 we can check for 2 meter, which is also on a normal value. And let's go to UHF, which is 43, and yeah, there is a normal value as well. So we have seen that it was not completely on 20 watt, so we could adjust it a little bit so that we really would have a reading of 20 watt, but that is not in the focus right now. So we just want to find what the problem is. But well, what we can say so far is that all the settings are okay. So there nobody seems to be in before to increase it to maximum and stress the finals by doing this. So this is not you know, the reason why something died inside. And secondly, we can summarize that our exciter stage on the main board is obviously fine, because otherwise we would not have power on 2 meter and 70 centimeter. So we simply have no power on our normal short wave bands. And yeah, well, we now have to check if there is something wrong with our final. Maybe that really the final transistors died, or maybe there is something wrong which with the TX or RX switch. So that is what we're gonna check next. Yeah, so let's crack open the radio and see if there is something obvious. Okay, there is one step we did not do, and that is to check if we have receive on our shortwave frequencies. And as you can hear, so on the 20 meter band receive is available, so no problem whatsoever. And okay, so that was important to prove that there is no problem with receive, but that is fine. And yeah, therefore let's open the radio and see what we can find. Okay, so we are in, and what we have here is this part is our shortwave and 50 megahertz amplifier, and here's the little relays and all the coils and capacitors which are down here. So this is our low pass filter part, and here this is our VHF and UHF amplifier. So you can see this is the track up there. So this is our antenna connector, is a end connector for VHF and UHF, and this is our PL connector, which is our shortwave and 50 megahertz antenna output. And yeah, so this both are the final transistors here in the shortwave PA part. And well, looking over the board, so there are no obvious yeah, burning marks or whatsoever. So it looks all nice and clean. So you know, I cannot say that there has something happened, something obvious happened to the circuit. So everything looks nice and clean. So you know, there is really nothing to complain. Well, so therefore next will be to check if we have the voltage available, which we of course need for our power amplifier. And yeah, so that will be next what we're gonna check. And I want to check, don't know if you can see it, but we have here two little fans. So I'm still looking for the cause why you know, the transmit fails, and maybe if the fans doesn't work. I mean, I recognized that minimum one fan works when I push the PTT, but I want to make sure that both work. And so that will be one test. And yeah, secondly, we need to check if all the voltages are available here in our final stage. Okay, what we gonna make sure right now is if we get the exciter signal at the input of the power amplifier. And radio is set to 21 megahertz, and I've set it to FM to get at least the carrier. And yeah, so that is what we're gonna check right now. So I'm now probing the input, and yeah, so what we can see is this is the exciter signal at the input of our power amplifier. And yeah, let me get it a bit closer. You can read the frequency counter, and it is really a signal of 21 megahertz. So that is what the radio is set to. So that is right as well. And now we do the same exercise on 18 megahertz, just to check if the frequency generation in the PLL and all what is in front of the exciter is working perfect. So I've set the radio to 18 megahertz, and yes, so what we can see is that it is 18 megahertz, and the driver signal is available, and maybe that down there is interesting as well. So the driver signal is 18.4 volt, and yeah, according to the power formula, that means yeah, let me calculate it. Let me calculate it right now. Yeah, where is it? So it is 18.2 volt, and according to the formula, that means we have 6.6 watt at the output of our exciter, at our driver. And that makes sense, because the 857 is using as exciter the same stage as it is used in the 817 as power amplifier. And as some of you might know, the FT-857 has a power output of 5 watt as QRP unit, and yeah, so that may make sense. Our exciter is working in the correct manner, and the circuitry in front of the exciter seems to work as well. So yeah, we need to find the problem here in our final stage, because yeah, when we are probing the output of our power amplifier, let me do it this way. Yeah, you can see there is almost no reaction, just a little bit, but that is definitely nothing. And well, therefore, let us check our voltages, which are now very important to read. And what I want to see is if the power, our DC power or DC voltage, is available at both collectors of the final transistors. Yeah, and as you can see, so that is the left one, so I'm probing down there, and now the right one, and yeah, there you can see we have our 13 volt available. And what we can check as well is if our Beer's voltage is available. So the middle of this 3 pins is the base, and we can read approximately 1.5 volt. So that makes sense as Beer's voltage. So Beer's seems to be there as well. And now we can check our signal at the base while we are transmitting. And yeah, okay, so this is a little bit lower, so we have to increase it a little bit. And yes, so the drive signal at the base is available, and that is the second base. And yeah, you can also see the bias. So when I'm touching the base, you see the line on the scope jumping up. So that is simply our bias. And yeah, when I'm then pushing the key, you easily see that at the base our signal is available, but there is no amplification. So maybe there is really something wrong with our finals, but yeah, we cannot measure it in circuit, even not or also not with a component tester, because all is very low impedance around the pins. So yeah, it is nearly impossible to check the final transistors in circuit. So yeah, I think I have to take out our PCB here, and that is I guess also a good idea, because then we can see the other side of the PCB, so maybe that we can find damages at the other side. So in any way we have to take it out and see if everything is fine underneath. And the other information, or the other check I wanted to do, you may remember, I just wanted to see if really both fans are working, and I can confirm it. Both fans are working, so that is not the reason for failing. Yeah, board is out, and after first inspection, yeah, you know, there is nothing obvious, so it seems to be okay all over the board, so nothing to complain so far. Well, I guess I really have to take out the finals just to check what the status is. Yeah, because as I already said, it is really difficult to check if they are okay or not. Well, okay, I decided to do a step in between. I just connected the output of our power amplifier directly to our dummy load. So now the complete low pass filter, which is here behind the power amplifier, is disconnected, and we have a direct access to our power amplifier. And well, with the power amplifier directly connected to our dummy load, yeah, let me check. We need to go a bit higher to read what we want to read. And yeah, if I now push the power, the PTT, you see there is no power, but when we check again our input, oops, no contact, you can see that the input from the exciter is still available, and now the power is turned to the lowest, and when I increase it to the maximum, you see that the exciter is going up as well. And yeah, so I'm probing down here as before, and yeah, as I said before, we are really directly behind our power amplifier. Nothing is connected behind, so the fault can't be anywhere else. So now we are again very, very close to our final stages, this both. And yeah, we need to take them out, so I wanted to avoid it, because it is always stress to the PCB when you have to unsolder them, and well, in case that they are alright, you know, that is not really nice for the PCB to put it out, to put it in and out and in again. So that is not a good idea. So that's the reason why I decided to do it this way, because yeah, it is much easier than to take the finals out. Okay, first transistor is out, and I've already connected the transistor to this component tester, and well, let's switch on the component tester and yeah, see what we have. So we have a short circuit on green and blue. Green and blue. So blue is the emitter and green is the base. So yeah, that is the reason why we do not have any amplification anymore. So yeah, now we have the proof. We have definitely a faulty final, and I guess both of them are faulty, but anyway, if only this one would faulty, you never would only change one, you always should change both. So that is what we have to do here as well. We have to remove the second one as well, and of course we will check the second one as well, but well, I really think that it is faulty transistor as well, but yeah, let's check and see. Well, and the second transistor as well, it's also connected to the component tester, and let's see what we have. Yeah, unknown faulty component. So that means it is definitely faulty, but in a different way compared to our second one. And if we check it with the multimeter, we can find that on this component it is open connector, a connection between base and emitter, and in this case there is a short between base and emitter. So we have both transistors faulty, but in a different way. So this is open on the base emitter junction, and this one is shorted. So anyway, that doesn't make any difference in the result. The result is it is faulty, and these transistors are not very cheap, so the owner of the radio has to decide if he wants to get them new, or what we should do. Well, but in any case, what we need to do is to clean the board and the old or this solder joints, so that needs to be cleaned, and then we have to put this this wire back. You can't see it, sorry. We need to put this wire back here to the PCB, Yeah, and then we can go ahead, but first we need new transistors, and as always, we do not know if there is an additional fault. I mean, I don't think so, but you never know. I mean, everything else was okay in the behavior, so I didn't recognize anything which seems to be wrong, but you never know. So we need to replace the transistors, and then we know if it was all or if there is something additionally. Well, while we are waiting for the new finals, which are ordered, and well, you can see over there we have our final stage with the low-pass filter, and it is waiting for the new final transistors. And meanwhile, I have taken the radio apart, so I've taken the main board apart from the chassis, and that is because I want to regrease the exciter stage heatsink. You may know that the exciter stage in this radio is similar to what will be the final stage in the FT-857, the QRP unit. And yeah, having a look here onto the board, let me see where it is. 1 second. Well, yes, down here. Here we have the exciter stage. This both MOSFETs, which are soldered directly on the board, and on the other side you find this heatsink, which is one way connected with the MOSFETs through the PCB, and on the other side it is connected with a chassis as big heatsink. So this is very important, that the heatsink has a good contact via this grease to the chassis. And therefore I decided to take it apart and re-grease the exciter, so the driver, and the pre-driver as well, because you may see here the second block, and this is a heatsink which should work through the PCB itself, and on the other side we have, if we flip it over, we have here the pre-drivers. So pre-driver and driver are really important to heatsink, and therefore, yes, this is an intermediate step to clean it and to re-grease it, and then I will put it together, and we can be then sure that nothing is wrong with the grease and the contact it should make between the heatsink, the chassis, and yeah, this heatsink here on the board, which is connected through the board and soldered through the board with our exciters, which are down here. So that is what I wanted to show you. Well, to be honest, I really hate this grease, because you have it always at your fingers, and well, so don't like it. Anyways, okay, so don't put too much onto it. Here I've put a bit, and here, as you can see, so that should be okay. And now we have to fit back the PCB to the chassis, and well, you always have to be very, very carefully that you do not match any wiring, which is of course here as well, and then you need to fit it that the screws will fit into it very easy. And most important are these screws, which makes the contact between the both heat sinks, as we have seen it before. So these both screws are most important, because they really will put some force to press it together, and that is really important, that our MOSFETs can really heatsink all the power which are dissipated in the MOSFETs. So that is where you should put some focus on. Okay, the PCB is back in, and all screws are back in. Now I will install the front panel, and of course the front side of the radio, and so then everything is really prepared to finally put in the new final stage, the new final transistors, which I'm still waiting on. But well, we are really making progress. Okay, that's it for the moment in time. Everything is nice and tidy, so we can wait now for the finals to come, and then we go ahead. Alright, finally the parts has been arrived, and well, we can succeed with our repair, so we can now replace the finals. Here are our two new ones, and yeah, let's see that we get this sucker running. Okay, so the PCB is back in, and I fixed the PCB already with some screws to have it in the right position. And this here is one of the newer, not of the newer, of the new MOSFET final transistors. And well, you should not solder it directly in, because it should be really centric. So therefore I put these both screws into it as well, to be sure that it is in the right position. And then I'm gonna solder it in, but First of all, we have to put some new grease under it. It is just the process that you really have the transistor in the right position. And well, with the new final transistors as well, you can see, oh, that is interesting. So this is a bit different because I had to cut off a little bit from this legs from the first one I take out of the package, but this one has already shorter legs, so that is really interesting. So so that are obviously different batches. Anyway, yeah, I do not really need to cut it, so that means I put grease under it, and I put the screws in just to get it in the right position, and then I will resolder the transistors back in. So now we're gonna re-grease our finals, so they just are laying in, so they are not fixed yet. So, but first, as I already said, it is very important to get a very good contact to the chassis, which is at least the heat sink. So that is very important, and therefore we just wanna grease it new, and then after that we will be able to fix the transistors with the screws, just to make sure that the transistors are really centric. So as I already said, that is really important, because otherwise, if we would try to just screw it in, we could have the problem that the holes doesn't fit really, and well, you know, that is then really a problem afterwards. So it is really better to do it like this, and then you definitely will not have any problems bringing stress to the board, because you know it is not really centric. Good, let me do the soldering off camera, because that is really boring, and yeah, I show you the result afterwards. So okay, the new transistors are in, and the temperature sensor is also back to its position, and around the temperature sensor we have grease to get the heat to the sensor, that yeah, finally the sensor knows when the finals are getting too hot. Well, by the way, I mentioned wrongly that these are MOSFETs. That is not true. We have bipolar transistors in here, so that was wrong. But only by the way. Okay, now we are so far that we can switch it on and check if we are successful or not. Okay, radio is prepared for testing. So first of all, we need to perform our BIOS setting, and therefore the first I'm gonna do is turn the pot for BIOS fully counterclockwise. So that is what I'm gonna do right now. Okay, so pot is completely counterclockwise right now, and yeah, our power supply is connected, and yeah, what we need to do is adjust our BIOS current to 300 milliamp. So let us switch on the radio and hope that we do not see magic smoke. You never know. Okay, so let me switch it on. Here we are. So radio is on. So you can see the display is illuminated. And well, so radio is set to SSB because what we don't need for BIOS setting is any drive. So we need the amplifier only with DC supplied, but no drive, and therefore yeah, as I said, it is on. Is it? Yes, it is on upper sideband. So therefore, let me check when I'm gonna press it. Yeah, I have set, as I said, the pot for BIOS fully counterclockwise, so we should not read anything right now. So let me press the PTT. So PTT is pressed and no power. So you see a little bit while I'm talking. So that is because modulation get into it. So I have to be quiet. So watch the amp meter. So we need 300 milliamp without modulation. So I'm quiet right now, so just simply watch it. Yeah, you see how difficult it is, and the pot is quite touchy. So yeah, I gonna switch off the camera and try to bring it to 300 milliamps. Yeah, you see I'm able to adjust BIOS current, and that is definitely a good sign. I mean, we finally don't know if it works, but up to now it looks really nice. So no magic smoke so far. let's hope that we want to see magic smoke. And yeah, let me adjust the BIOS and I will be back. Yeah. So it is clear that it is moving a little bit, because as more temperature are absorbed by the finals at more BIOS current we are reading, so that is normal. And I would say this is a good value. So watch, it will increase while the temperature is getting up. Yeah, so that means I'm quite happy with it. And well, so next will be to check if we see something on our watt meter. So let me try to get it in for you. And I will not fully power it, as you know, we will not overdrive it right from the beginning, and I've still the amp meter in between, and amp meter only works up to 20 amp, and this radio is fully fully power could be exceed 20 a little bit, so I have to be careful. Okay, but wow, have a look, have a look. So what you can see is modulation, and we have power. Great. So it seems everything is good, and I'm gonna switch now to FM to have a constant drive and see what our power meter is telling us. Okay, so radio set to FM, but I have limit the RF power output to 45, I guess. Still, because I have the amp meter in between, and that's the reason why I want avoid to have full power. So let's see what happens when I press PTT. Yes, have a look. So we have power. Great. So that are really good news right now. Okay, so let me get off the amp meter in between, and then we can check it up to the limit. Okay, I've set the radio to RF power. Let me put down the volume. So I have set RF power to 100 watt. So yeah, as you know, you can adjust it here, as you see. Now it is to 100 watt, and we are still on FM. And well, so let's check the power output on FM to be sure that the driver is working correct. And 95. So that looks pretty nice, and yes, we could increase it a little bit up to 100 or beyond, but I'm not a fan of pushing the radio like hell. I always leave it a little bit under the limit, because that is definitely good for all the components inside. So therefore I gonna leave it, and I do not want to change it. So therefore I would say radio is ready, so I will now fully mount it back and clean it a little bit so that it can go back to its owner. And I hope this video was a little bit interesting for you, and if you like it and if it made a bit sense to you, then please give me a big thumb up for this video. Thank you very much, and catch you next time. Bye!